Hopefully you've been able to visit some of our other vendors here, are excited for this next presentation. I've been coming to this since its inception, and these presentations have been some of my most memorable sitting in here. Especially, I told you, I do nuclear security, federal government security for Southwest. Everything we do is on the perimeter, so I'm looking at very clear line detection. And we always look for layered technologies. So understanding what's going on in the AI world and cameras and how that can layer over top of what we do, it's a marriage made in heaven for an end user who needs holistic and fine-tuned detection for their perimeter. So as I mentioned, the last presentation was all about hardware, what Bosch can do, what their new technologies are doing, what those cameras are capable of, because then we want to layer on top of that what we can do with AI, how we can bring it. So Matt and Nils, did I say that right? All right. Number 2 was much better. Anyhow, they're going to bring a great presentation and share with you guys what they can do, what's coming up, what's presently available, and where the future is with AI.
With you the latest in our analytics portfolio. We brought a lot of stuff with us, a lot of new technology, so if it's too fast, you're also invited to talk with us about the details of this technology at the Tinker table, where we have more time to talk about that in detail.
I do love interaction though, so if you guys have questions as we go, chime in, please. So dialogue, not monologue.
All right, so let's have a look at the overview slide. So we work our way kind of through all the areas of a building. So number 1 will be the vehicle entry point. We've already talked a bit about LPR. We will talk a bit again about it right now. Then we will talk about the perimeter area and all the improvements we did, which is massive. Then we will talk about the building entry point, which will be our gun detection system, where we also have a significant improvement compared to last year when we first introduced it. And finally, we'll talk about the building interior and our new IVA Pro appearance solutions that will also help, on the one hand side, to detect more specifically what kind of people are in the building, but also it will significantly help in reducing time that is required to search through video footage. So let's get started. The vehicle entry point. So one thing we are introducing this year in 2 weeks with the next firmware release is our license plate recognition. So you can put this on the cameras, and I also let the video play. So this is basically embedded in the camera. It runs in the camera. No additional servers needed. It is available as an additional license, and you can read all the license plate information with this additional IVA Pro license plate recognition package. And it will not just tell you the license plate, but also it will give you information about the country and specifically for the US also about the state where this vehicle or where this plate is from. And additionally, you can layer that also, of course, on top with our hardware technology. So for example, if you think of a vehicle entry point, what you see on the right-hand side in the video, especially on the windshield, you might see some glare. And if you don't just want to detect the license plate, but also want to see the person sitting inside of the vehicle, then our polarizing filter comes in handy, which you can also add on as an accessory to our Dinian 7100i camera. And this will allow you to not just detect and read the license plate, but also get that picture of the person actually sitting behind the steering wheel.
I think there's something interesting here. AI, for a lot of reasons, has sort of taken the spotlight in the last few years, for good reason. But image quality still matters. So some of the things that Heist was talking about in his presentation, the analytics are only going to be as good as the picture you take. And for license plates, for example, this algorithm runs behind our license plate capture mode, where the camera is optimized for catching plates, because nobody needs the plate at 2 in the afternoon. They need it at 2 in the morning. That's when the bad guy's out. So this image quality conversation, I think, has gotten a little bit lost in the last few years, but it's still super critical. It's just, instead of us watching the cameras for good image quality, the analytics are watching the cameras for good image quality. But it is still very much relevant to all of these things, and the polarizing filter is another great example of that.
Exactly. So the question was how much the package costs. So list price, it's around $400 for the license plate recognition. And if you also want to have the make model recognition, you can also have both license plate and make model recognition, which is then around 700 list price MSRP. So the question was, is this the overall license or per camera? This is basically per camera because each individual camera has the software running to detect the license plate.
Absolutely. Absolutely. So once the detection is made, it becomes like any other analytics detection. So we have the benefit of schedules and areas and all kinds of things. We can feed various VMSs, et cetera. Oh, I'm sorry. So the question was about illumination for plates and IR reflectivity. So we have a license plate capture mode. It's one of our drop-down lists in the camera, what we call scene modes. So there's a number of different scene modes, one for gaming, for example. So this particular mode is pre-optimized for exactly that. So the IR works in conjunction with the imaging. It resets the shutter speed, et cetera, to make sure that we minimize motion blur. So again, the idea is to get plates when it's dark. And once the camera is in the license plate capture mode, it's typically not going to get, during the day, it'll be a pretty traditional looking picture, but at night, it's pretty specifically looking for a license plate.
We can not just use this information in real time. So of course, we're reading license plates all the time, and also we are detecting the make and the model of the vehicle. So for example, we can say that's Ford Mustang, whatever. But we also take this metadata and integrate it into the video management system. So this means also in the video management system, and with video management system I mean BVMS as well as other third-party systems like Genetec or Milestone, we integrate that information and you can leverage this if you do a forensic search. So for example, if you want to find a specific vehicle with a certain license plate, you can search. Like when you have those licenses deployed on the camera, they are generating all this data, and you can search through it and find that specific vehicle again. And you can, for example, also leverage the data from the make and model to search for a specific vehicle based on make and model. So this can also not just be leveraged in real time, but also in a retrospective way to make investigations faster and more time efficient. Okay. Since we've got quite some ground to cover, let's switch over to the perimeter, where we will tell you why we have the best perimeter solutions. There are 3+1 reasons. Number one is we have the best cost solution. Number two is we have the best performance. Third one is we have the best integration. And the +1 is we have the easiest setup. And we're going to show you why this is. So first of all, best cost. I play these videos, but I think they've already been shown in the previous section. One thing where we are really good in is detection distance. So some of the competitors, they only do half of the distance. So this means if you only have half the detection distance, you will need twice the cameras. And it's not just the cameras, as you all know, it's also the cabling. So in terms of total cost of ownership, you're going to set up a pole, you have all the wiring, you have the maintenance costs tied to that camera. If you have twice the detection distance, it effectively costs you less because you only need one camera to cover the same ground. And as you can see in those videos, we can get up to distances of 524 foot with a single camera, which is quite tremendous. Second thing, in terms of performance, we made some massive improvements. So what you can see here on the right-hand side is our previous IVA Pro Perimeter solution, which was already great. We received a number of industry awards, and we just exceeded that performance by a wide margin again. What you can see is on the right-hand side our old one, which was great already, and now on the left-hand side, you can see our new improved version, which has layered on top not just our classical algorithms for motion detection, but also now a specific layer with deep learning. So what you can see is on the left-hand side, we are detecting that particular person much earlier. So let's take a look again. It loops through. So now we are detecting it on the left-hand side already, that person, while on the right-hand side, it takes some moments longer. And sometimes it can be critical because you know a couple of seconds earlier when there is an intruder. That's the increased sensitivity part. The other thing is motion algorithms itself, they are sometimes prone to false detections since, for example, moving objects like here, the US flag, they might cause the system to think that there is a person or there is a kind of object that's moving. So you can see in the right-hand side, there is some motion detected, while on the left-hand side, with that layered approach, by leveraging also the deep learning capabilities, we can get rid of those false detections.
I'd just like to zoom out real quick on what Nils just said, because this is really important. In general, in analytics, we've seen a transition over the last few years from motion-based detectors to object-based detectors, and that's really the transition to AI. The AI object-based detectors are vastly superior in terms of accuracy and false positive suppression. But they have this one glaring hole in that they require more pixels on target, and they don't recognize things that they weren't taught. So I used to do a demo regularly where if somebody was walking by with the dog, the person was bounded, but the dog wasn't, because we didn't teach it anything about dogs. It doesn't know about dogs, which is different than the old algorithms. So what we've done here is layered the two. So we still have that long detection range, the ability to pick things up way down the fence line, things that don't necessarily look like a person or traditionally people who are disguised, and you'll see that here in a minute. But we also get the benefit of the false positive suppression that we get from the neural networks. So layering these two technologies on top of one another, I think Jeff mentioned something about layered technologies, really changes the way that we do perimeter detection. I think really opens up the market potentially. You know, I'm sure many of you guys work on high security places, nuclear power plants and Air Force bases and whatnot. They typically use thermal for this kind of thing, and I think they'll continue to. But I think there's also a whole set of customers and users out there who could benefit from perimeter intrusion systems, but don't really have thermal money. And so now, using these algorithms and that new Dinian 7100i that Heist talked about, you can do 400-foot sections of fence on an optical camera. It's essentially 90% of a thermal's performance at 30% of the cost.
All right, and one other thing, we talked about military bases, might also be animals at the perimeter, right? You might have some wild animals walking into the fence, causing false alarms or nuisance alarms. And what we also built into this new mode is a specific deep learning-based detector for small animals. So this means you can now have the ability to also specifically suppress false positives or nuisance alarms caused by animals running into the fence, which is also huge because previously this was kind of one of the downside of those systems. You really had to tweak them for all those instances. Everybody who worked with such a system, then you have some kind of speed filtering or size filtering or whatnot. And we now built that into that additional layer that we also, because we know animals cause a lot of trouble at the perimeter, that we make sure that those are not an object of concern anymore.
To my knowledge, this is the first of its kind that, most detections are centered on positive detections, something we want to detect. To my knowledge, this is the first time anybody's ever built a detector specifically for the purpose of false positive suppression or nuisance alarm suppression. It's pretty cool.
Right, and now comparing this also to the competition, what you can see here, I need to explain on the left-hand side basically is our performance, and what you can see is a person behind a blanket walking across that street. And as you can see is, on our Bosch camera, we pick up that person even behind the blanket. So you can't see the person, yet we do detect this person. However, both competitor products, they do not detect this person. And that's because they are kind of trying to detect an actual person, why we also have this motion detection capability, also with some additional filters where we know the height of a person and everything, and we take all these things into our algorithm and make a classification and a decision based on that. So now you can see the blanket is gone. Now also the competitor products pick up the person. But if you have a blanket in front of you, you can just walk right across the fence. And to me, that was shocking at first, because this means for most of those products, you can just put a blanket in front of you and walk right in. And this is, I think, the powerful thing about our layered approach, that we not just use the deep learning, which can be fooled by a blanket, pretty easy, but that we really layer those technologies on top of each other. Exactly. If you would hide behind some other object, it's the same, right? So you can test that. It's basically also sensitive to objects which have the size of a person and things like that. So
so the question was set up required. If I'm going to regurgitate that to you a little bit. So there is some calibration steps that are required on the front end. We actually have a demo toward the end of this, or a video of exactly that. So we have actually also leveraged AI to make that calibration process much faster and more scalable, because that was kind of one of the gotchas of the previous generation system. Is it took a while to set up, and it took some know-how to put those filters in place. With this new version, much of it works out of the box once it's calibrated. Then you just tell it what you want and what you don't.
So right, the calibration process was the gotcha.
Yeah, absolutely, absolutely. The other thing is, I think this is, it's interesting to a nerd like me, is a lot of times we think of this in terms of line crossing. So we are leveraging a decade worth of perimeter intrusion stuff. We typically use multiple fields. So an object must first be in field 1 and then be in field 2, and it has to be the same object. Much more robust logic. And it's just an example of, it's not that nobody else can do that. It's just we have more stick time doing this particular use case than anybody else in the industry. So the hard part with the neural network detectors is they're looking for specific objects. So this has the ability to say, I see something, I don't know what it is, but I do see something happening. And then you can decide whether or not that's of value.
I think there's another question at the back of the room, or? Yeah. Correct. So this is kind of it's getting tricky. We have this deep learning detector specifically trained to detect an animal. But if it's not sure, if it looks a lot like an animal, if it's the same size, then it would rather raise an alert just to make sure. Yeah, but there is also a setting where you can determine how much it should lean towards one of them. So if you are rather interested in reducing the number of nuisance alarms, you could also arrange the setting in a way that this would then be filtered out. Or if you want to be really sensitive because it's an important building, then you could also say, okay, let's rather raise an alert and let's make sure that everything is raised. We already talked about best cost. We talked about best performance, even behind the blanket. Now I have also one slide on the best integration. So this is an example with the Genetec VMS. So one thing we haven't talked about is we do not just detect that there is a person, but we also give you additional metadata, and this is the precise geolocation of that object. So we don't just tell you there is a person, but also the geolocation, so you could plot it on a map. And this is exactly what's happening here in the Genetec RSA plugin, RSA Restricted Security Area. The camera detects the person along with the geolocation, and now, as a second step, this intruder is visualized on a map. So you will, there will pop up a pin on the map and say, here is the intruder, and you will see the corresponding video. And now the powerful thing is, if this person, that's kind of the step 4 here, now moves from one camera to the next, there is an automatic handover. So it's not just visualizing on a map and showing you the video, but as long as this person leaves the field of view and walks into the field of view in another camera, there is also an automated handover. So basically, this intruder is now precisely, even behind a blanket, detect it with geolocation and hand it over between cameras. And this is what we mean with best integration. So it's not just the camera, it's also very well integrated, not just with our own BMS, but also other systems. And then finally, this question was already raised, what about the setup? And in the past, the calibration was a big pain point. We also heard that very loud and clear from the integrators. And we listened to it, and what we came up right now with is a patent pending solution, which we call auto calibration, which now also works with people. So what you basically see here is a person walking through the field of view, and based on that person, the camera determines with an intelligent algorithm the height, tilt, and roll angle, so all the calibration parameters. Florian, actually, our engineer coming over from Germany, he will also talk later a bit more about the technicalities if you're interested how it works. But basically, for you, it's as simple as if you watch the video, this person is just walking through. So you hang up the camera, one person needs to walk through the field of view. And what you can see is, on the left-hand side, it's capturing data, basically, based on that person moving through the scene. And now, after this person walks through the scene, you can see that it shows 2.8 meters, so around 10 foot of height, and it shows the accurate roll, tilt, angle of that camera, so you don't need to manually enter or measure anything, you just need to walk through the scene to make that. And I think that also should answer the question on the installation part. That's one thing we also came up with. So it's not just superior detection, it's also easier setup to make it easily deployable on scale.
I was part of Bosch's field engineering team for years, so these guys are on the development side. This used to be a manual process. I used to literally have to walk through the field of view with my laptop and measure myself in different locations. It took me 10 to 15 minutes typically to calibrate a camera, and I was good at it. So imagine a technician who had never seen this before. It just wasn't scalable. Now, not only can this be done literally in a matter of seconds, but it's a more accurate calibration. It is remarkably accurate, and that accuracy translates to things like the RSA map. So if the calibration is spot on, then your location data that's coming from the camera is also spot on, normal garbage in, garbage out. So this is a huge leap forward in deployability and accuracy of the system. There's a process that you have to access, but once you access that process, it happens automatically. You just click the go button, basically.
All right, so just to recap, 3+1 things. Best cost, because we need fewer cameras. Best performance, because we also suppress false positives. Best integration, for example, with Genetec. And the easy setup with the auto calibration.
They are available today, absolutely.
And this is all available today. So next thing, building entry point. And we've actually introduced last year here at this show, or showed it for the first time, our gun detection system. We've been pleased in the meantime that we also received this year's CES Best of Innovation Award, which is quite a big thing. Just to put it into perspective, from all Bosch, which basically is a 100 billion company with 400,000 employees, there were multiple products applying for this award. And this is the only product which got the CES 2024 Best of Innovation Award. And what the system does is basically we always refer to, and Matt's going to explain that there are basically 3 ways that you can know that somebody has a gun.
Yeah, even here in this room, if you want to know that I have a gun, of course you can see that I have a gun. Unfortunately, in many cases, the first indication is that you hear a gunshot. Hopefully people haven't been there too much, but and the other way is you can search me for it, either manually, tactile search, or with some sort of technology, millimeter wave or magnetometers. So we're essentially doing 2 of the 3. Any brandished weapon that you can either see or hear, we're detecting. And of course, we can layer this also with search methods if you want to cover all 3 bases.
Correct. So this is basically our gun detection system. We introduced this last year, and since then, we significantly improved it. Florian, the engineer, will also tell you all the technical details, how they made that possible. But one thing we, for example, improved is the detection range. I think Matt's going to speak to it. He's also the one who's in this video, how we actually achieved to also have a detection range of this of up to 100 yards. So if you think of this in terms of a football field, we could basically cover the whole length of a football field, which is massive.
So the question is scaling this to multiple cameras as opposed to these specific designs. So the short answer is yes. Technically, we can run the algorithm on any camera. However, and this is a gotcha that I point out to a lot of folks, because there are a number of companies out there sort of purporting you can slap this gun detection license on any camera, and voila, you're going to see guns everywhere. The problem with that is most general observation surveillance cameras are 90+ degree fields of view, and guns are little. It just doesn't have the pixel density. So technically it will detect a gun if the gun's right in front of the camera, but it's usually not. The reason we've chosen to make more dedicated designs is specifically to address that problem. Focus on funnel points, so it's not necessarily an entry point, although it usually is. But this next long-range gun detection system is kind of the next iteration of how can we get some additional detection in other parts of our facility without just trying to slap it on every camera. So we don't do any facial recognition. Sorry, the question was, could this system integrate with facial recognition? We don't do facial recognition. There are a number of companies that do. Fortunately, the pixel density required to detect a gun also lends itself very nicely to facial recognition algorithms. So there's absolutely no reason why we couldn't do gun detection on the edge with our system and then also feed that to a facial recognition software and utilize them together. As Nils teed up here, we had our initial gun detection system with the overlapping views. That was mentioned back in the back. So one of the other things we learned very early on in testing is that the probability of detection goes up dramatically if you can see the weapon from two different angles. It helps get us around line of sight issues. And also a gun pointed directly at a camera has almost no visible profile. So this ensures that one of them sees the side of the gun. What we very quickly got was a request, hey, this is great, but if somebody's at my door with a gun, they might be too close in some cases. And this is all about pushing the detection perimeter out. So the next iteration that we're developing, and what's shown here in the video, is drive aisles. So most major parking lots, commercial parking lots, whatever, have these drive aisles where you've got two parallel rows of cars, and then the aisle that they drive between, two more sets of cars, the aisle that they drive between. So theoretically, anybody who's approaching my building through my parking lot would have to get out of a car and step into one of these drive aisles in order to come. They're not going to weave their way through all the cars. So what we've done here, you can see we flipped it into a portrait mode, and we're shooting down this drive aisle. That cart in the far field is 300 feet away, and we are successfully detecting long guns at that 300-foot mark. Handguns start to become visible at about 130. To put this in perspective of time, when I just walked briskly from the back to the front, it took me about, if we say the camera is at the entrance, nearly a minute, 50 seconds to walk all the way up. 50 seconds of warning for this kind of event is something that absolutely can change how we respond. And that's really the whole thing, is to push the detection perimeter out, both in distance but also in time. Can we do anything with acoustics as well? So much like the funnel point solution that we have, where we have our gunshot detection incorporated in that system, we're going to be doing something similar with this. So the first question mark was the long-range detection and the right camera for that. And we think we've got that pretty close now. But absolutely, we will be layering it with our gunshot detection, just like the funnel point solution, so that you have two of those three methods of detecting a weapon.
Correct. So it's also visualized here again on the slide. So in this gun detection system, there is another sound-based component, which also detects gunshots, potentially even outside the field of view, up to a 75-foot radius. So that's what we also have as part of that system. Now, the other thing is, what you realize when deploying those systems, those are really good, as many analytics, in actually picking up weapons. But the really important thing is to distinguish between a weapon and any other object that looks similar. So you want to detect the weapons, but you don't want to have the false positives on smartphones and some other objects which are carried around by people. And that's in the end the trick. And what we realized is our system already does a great job in making that distinction right at the camera level. So what we found in tests when we deployed it in the field is that at a current level, when you have, for example, at an entrance, people walking through that entrance, that around 1 in 3,000 people causes a false positive by some weird gesture or a smartphone or whatever. And while this is already great if you deploy it on scale, you might want to have an additional filter that further brings down those false positives. And also that's something where we got inspired, and we also showed that last year, by the NFL instant replay technology. So in the same kind of fashion, we also try to bring down the false positives. So think of a usual NFL game when the referee makes the call on the field. And he has to do that in real time, which can be challenging because he only gets to see this whole play once. And if you also look at NFL history, 40% of all the plays that have been reviewed have been reversed. So there's quite a significant amount of decisions by referees that are actually wrong. So does this mean the referees are bad? No, it doesn't. It just means it's incredibly hard sometimes to make a decision in real time. Now, what we do is we take this decision from the camera as the call on the field. And once this decision is made and it turns out to be a weapon, we send it up to our instant replay booth, if you want, which is the cloud at this point. And there it's reviewed. And you can imagine the review is done also by a neural network, a much larger one, but this has the whole clip and can replay it and loop it over and over again, very much in the same way as the guys in the NFL games do it. And you can imagine by this we can achieve to significantly reduce the number of false positives of the overall system. And maybe Matt can explain how we kind of imagine this integrated as a whole system.
Yeah, absolutely. So a couple of points on this. Any of you guys who have been in my sessions before have probably heard me say this. The trick to video analytics in real life is never getting them to go off. It's getting them not to. And this is something that you mentioned, putting gun detection on every camera. I was working with a school district. This was probably a year or two ago. And they had one of these where we just slap a license on every camera, and all of a sudden alerts start going off on the phone, and the administrator goes, oh, it's lunchtime. Now all the false positives I get from my phones, well, that becomes completely unusable at that point. So the idea here is to drive the false positives to near zero, particularly for a detection as important as a gun. So the way we see this is kind of in a secure by default, or for any of you guys who have done access control, sort of a fail secure concept. So if you take our entry point gun detection system and the edge thinks, oh, I see a weapon. That's the call on the field, as Nils mentioned. Right then, we can lock the door downstream or whatever barrier that we have. In the meantime, that clip goes up to the cloud for review. We're typically getting an answer in 5 to 10 seconds. I would say 7 is about the average, network latency aside. So if we've positioned this equipment properly and it comes back, call overturned, they held their Stanley Cup in a weird way, then the door just unlocks and the person never knows we did anything. So we didn't disrupt anything. However, if that call comes back confirmed, now not only is the door already locked, but we have the ability to start initiating our response based on that higher priority verified alarm. Did everybody hear that question okay? Because it was a lot. The question is, are we reviewing any additional views? The short answer to your question is no. We're taking the initial detection, we're taking the view from the camera that detected it, and adding it. Now that said, we can certainly enroll multiple cameras in this system. So if we have 2 or 3 that go off, they're all going to be reviewed, but they can't pull from each other, if that makes sense. Exactly. Yes, that's a great question. The question was, can we get a human in the loop for this detection? So the short answer is yes, absolutely. What we find is, statistically speaking, our false positive suppression with the edge-only detector is by far industry leading. But as Nils mentioned, when you start to do it at scale, you do have some alarms that you need to work with that will end up being a Stanley Cup or a phone or something, umbrella, and a lot of times there's a gesture component with it as well. So the bottom line is that needs to be verified and evaluated. If it makes sense for a customer. We've got a major customer in Tennessee that they've chosen to do that. They have a SOC, and they would rather just deal with it. They understand that it won't be passed on to the actual location until it's gone through a human. So they've chosen to do their verification layer entirely human. We also offer this automated verification layer, which is the cloud. Ultimately, you need a verification layer. You can have multiple verification layers. So it might also make sense to first cloud verify, then human verify. And if you actually saw in our console on the FPCon, you would go from alpha, it's going to go to Bravo if there's an edge detection. It goes to Charlie if that is confirmed by the cloud. And then once the operator says, yes, I see a gun, then it goes to full Delta. So that exact process that you're describing is built into that console.
That being said, let's jump to our last point, which is the building interior. And we basically have 2 examples here for that. Basically, one is from a correction environment and one from a government environment. But I want you to take a look at this picture. And what you can see in this picture, there are 2 people. So with our standard analytics, which is coming out of the box, which we call IBA Pro Buildings, we can already detect people. So what we will do is we will tell you where the people are. This is the bounding box around the person. And we will also tell you, location and this classification. There's a person in which position. Now, we're releasing an additional capability, which we call IBA Pro Appearance, which will tell you more about this person than before. So this means, in this case, with our IBA Pro Appearance, you will additionally get things like, for example, shirt color. So in this case, we will not just tell you that there are 2 people, but we will also tell you there is one person with an orange suit and one person with a black suit. So if you think of a correction scenario, it might not be of concern if maybe in a hallway area there is a person walking, because it could be the guard. However, let's say after hours, if there is a guy with the orange suit, you better want to look at this. So, and this is exactly the additional scene intelligence that you gain with our IBA Pro Appearance, since we not just tell you there is a person, but we also tell you those additional attributes. And it's not just clothing color, it's things also like backpack and glasses or other things. So for example, in a correction, you could maybe earlier detect a breakout attempt, or can actually check if there is a guard present. So I think you also had an example.
Yeah, we're running a little over time, but this is really important to me. So first of all, IBA Pro Buildings has 2 core classifications, people and vehicles. That's almost always what we're trying to detect, some variation of that. What we've done here, and in a lot of ways you can think of this Pro Appearance similar to the LPR make and model. We're applying additional granularity or sub-classifications to those 2 core classifications. So now, not just that there's a vehicle, but what does that vehicle look like? What is the make and model? What is its license plate? Same thing with the people. Not only that there's a person, but some attributes about that person. What color are they wearing? Do they have glasses? Do they have a hat? Male, female, etc. The other point I'd like to make, and this is where the people in this room are so important to us, and I encourage you to go to the Tinker tables and talk to us. So we started talking about this corrections piece about, could we say if there was an inmate somewhere too close to the exit, basically a breakout attempt. They were like, yeah, that's great, but actually day to day, that's not our problem. They came back and said, can you do a guard tour? These guards are supposed to go through this area once every hour. So we ended up writing a script that every time a guard went by, based on what they were wearing, it resets the timer to an hour. As long as they come back before that hour timer goes off, there's no alarm. It's ignoring all the inmates because they look different. So we're using the appearance. So just because someone walked through there didn't matter. It has to be a guard in order to reset that timer. And that day-to-day was something that we hadn't occurred to us, because that's not our business. That's their business. They're the experts. So I say that to say to you guys, you're the experts at your respective facilities. You're going to think of applications for this stuff that we never dreamed of. And we love to hear those problem statements. So get your gears turning. Talk to us out at the tables about things like that. Now that you've kind of seen a background of the technology, how can we apply it to your business?
Correct. And last point on that, you can certainly not just use that for real-time alarming. So, like saying, okay, there is a guard walking now through the entry door, but you can also use that in the same fashion as for the cars, for the vehicles. You can also use that for a forensic search. So this means all this metadata is generated on a camera level. It's running on the camera, and it's delivering that additional metadata to the video management system. This means if you have an investigation, if you are searching, let's say, for a person with a backpack that maybe stole something from your facility, you can now go through the video footage. You can select, I want to find the guy with the red hoodie and the backpack across the whole facility. And you select all the cameras, you press search, and you can narrow down the search results tremendously with those attributes. Because previously, what you had to do is you needed to search for all the people that went maybe through an area. Now you can say, I only want to have the people that were in the facility with a red hoodie, which already narrows down the results. Now you say, and additionally, which have a backpack, which further narrows down the result. And now you can also restrict on a time range. You can maybe say only from 9 to 12 a.m., which further narrows it down. So this will also enable to review video footage much more quickly and to find what you are looking for without spending a lot of time. Thank you very much. If you're interested in the live demo, please make sure to drop by our Tinker table to learn more about that. Thank you.
Yep.